Hello. I just wanted to give a little addendum to the lecture that hopefully you just watched that focused a lot on chemical formulas and chemical naming. I realized that I really wanted to also include the rules about naming acids, and that had not been included in the lecture, and so we're going to just talk about them very briefly here. We're going to talk a lot more about acids later, or a little bit more at least, about acids later on in the semester. Those of you who go on to 115 will talk a lot more in detail about acids later on. For now, I just want to point out that acids typically are going to be compounds, and we're just going to use X as sort of a generic acid here. But let's say we have a gas form of some sort of hydrogen-containing compound. When we dissolve that in water, if it's an acid, it's going to give off hydrogen ions. That's one of the defining really big aspects of an acid. And so, or according to one of the definitions of an acid anyway, again, which we'll talk about later on in a few weeks. For now, the big thing to key in on is that quite often, if you see hydrogen listed as the first element in a compound, that's your big first clue that what we're talking about is an acid, or possibly even more than one hydrogen. You might see H2X, or even, maybe H3X, but it's that hydrogen in the beginning, that hydrogen in the front, which is your big clue that we're talking about an acid. And so when we look at the acid naming rules, there are two main types that we're going to see in a class like this. One of those is what we call halogenated acids, where this X, this other part of the acid, contains something for a halogen. Remember that halogens are the next to last column in the periodic table, group 7. So chlorine, bromine, iodine, fluorine, etc. And so those are, if we have hydrogen plus one of those, it's a halogenated acid. And to name it, it's simply hydro, and then we insert the name, a part of the name of the element, and then ic acid. And so for example, if we're talking about HCl, so now Cl is making up the rest of our acid, that's a chlorine atom, and so we get hydrochloric acid. If it's Br, hydrobromic acid. If we have, this is what I want. If our X is maybe iodine, then that's going to be hydroiodic acid, HF. Hydrofluoric acid, and so on. And so that would be how we name our halogenated acids. Sometimes X is one of our polyatomic ions. And so, for instance, our polyatomic ion, remember NO3 with a 1- charge, is our nitrate polyatomic ion. And so HNO3 is an acid made up with that polyatomic ion nitrate. Another example, remember NO2 with a 1- charge is our nitrite polyatomic ion. And so we could have HNO2 would be an acid made up of using the nitrite polyatomic ion. And so to name those acids in which we have a polyatomic ion, if the ending of the acid, let's wait for that little box to disappear, there we go. If the ending of that acid is ATE, we can see in this box down here, if the ending of the acid is ATE, then the acid gets the name ic acid, with the root being the root of our polyatomic ion. And so HNO3, remember NO3 was nitrate, and so that's going to be nitric acid. PO4, our phosphate polyatomic ion with a -3 charge, and so we get H3PO4. And remember that formula just comes from our basic formula rules. PO4, phosphate, has a -3 charge, And so to counterbalance that, so the whole thing is neutral, we need 3 H pluses. So we get H3PO4 for our formula. And since it's a phosphate ion, it's phosphoric acid. Now, if the end of the polyatomic ion is ite, as opposed to ate, if the end of it is ite, as in nitrite, which is NO2 minus, then the end instead of ic is us, O-U-S. And so HNO2 is nitrous acid. And that's how we name acids. Pretty simple convention. Sometimes I go back and forth on if I include acid naming in this course, and I ultimately decided to because we're going to run into acids all the time. We're going to see acids, and it's important to know the same sort of naming and formula rules that we know for other compounds. Acids just happen to be a class of compounds by themselves, and so they get their own naming rules. The other thing that I did want to go over real quick in this little addendum, so to speak, is this naming flowchart. So I've put this flowchart together, and this is now up on the website. You just go under Unit 1 Materials. You'll see it right there. In fact, let's just show you where that is, just as a reminder. So we're here on the website. We go to Unit 1, Unit 1 Materials. We scroll down a little bit, and we see informational handouts, compound naming flowchart. And here it is. And so these are all the same rules that I went over that hopefully you just saw in the lecture. I just put them into a flowchart form. Makes it a little bit easier for some people to use as they are first applying these rules and first doing some practice naming chemical compounds. So again, the same exact rules that I discussed in the lecture. We now just have the flowchart to go through. And so let's just go through this real quick. Excuse me. And so remember, when you're naming a compound, the first thing that you want to do is figure out, are we dealing with an ionic compound or a covalent or molecular compound? And so the first question, is there a metal in the compound or NH4 plus? Is our first thing listed either a metal or our ammonium polyatomic ion? If the answer to that is yes, then we're dealing with an ionic compound. If the answer to that is no, if we're dealing with two non-metals, then we have a covalent or a molecular compound. And so if it is ionic, then we go through our naming rules. We're always going to have our positive ion listed first. And then we have to think a little bit about the nature of that positive ion. If that positive ion is ammonium, perfect. We just skip ahead to thinking about the negative ion, and that's it, because the name of ammonium is simply ammonium. If it is a main group metal, something like sodium, magnesium, calcium, aluminum, then the name of the ion is simply going to be the name of the atom. So remember, a sodium ion has the same name as a sodium atom. Sodium versus sodium 1+. We don't change the name of it. If our positive ion is a transition metal, it's iron, chromium, vanadium, anything within that middle section of the metal in the metals on the periodic table, then remember, in our name, we have to use the Roman numeral to indicate what the charge is on that ion. And so if it's an iron with a 3+, then we would say iron 3, then followed by our negatively charged ion. And so now we just have to determine, is our negative ion a monatomic ion or a polyatomic ion? If it's monatomic, then remember we just add IDE to the end of the ion. And so now we can put it together. And so sodium, and so NaCl, sodium, there's our positively charged ion, just keeps the name sodium. Cl would be a chlorine atom. Now it becomes a chloride ion. So we have sodium chloride. FeCl3. We can see that, just bring the whiteboard back up real quick. So first of all, we know that it's iron. We know it is a transition metal. And so we're going to have to include the charge in our name. And so it's FeCl3. Now we have to use our other information to figure out what that charge is. And so we know that Cl has a 1- charge, and we have 3 of those. So we have a total of 3 minus, which means that our total amount of pluses must be 3 plus. We only have 1 iron in there, so that 1 iron must carry with it a 3 plus charge. And so in our name, we're going to have iron, Roman numeral 3. And that's what we see here for our naming, iron 3 chloride. And then finally, if our positive ion is ammonium, then that's simply the name of it. NH4Cl is ammonium chloride. Now, if our negative ion is polyatomic, then that's perfect. We don't have to change the name of anything. And so NaNO3, NO3 is our nitrate polyatomic ion. And so we get sodium nitrate. Let's take a quick peek at this iron phosphate compound. So we have Fe3PO4-2. Now again, we have to use our other information to figure out what the charge of iron is going to be. We know that PO4, our phosphate polyatomic ion, has a charge of 3 minus. And we have 2 of those, as we can see by our subscript here. So we've got 2 of those phosphate polyatomic ions, so we have a total of 6 minus for our negative charges. That means that we have to have a total of 6 plus for our positive charges. We know we have 3 irons. That tells us that each iron has to be a +2 charge. And so our name is going to include the Roman numeral 2 for iron 2. And it's a polyatomic ion, PO4, so phosphate, so we just get iron 2 phosphate. And we would apply the same sort of rules here with CaCO3. Carbonate has a -2 charge. Or actually, that doesn't even matter because, sorry, this isn't a transition metal. And so we don't need anything different with the name. It's just calcium carbonate. And so those are our ionic. That's going through our entire ionic flow chart. If it's 2 nonmetals, if it's covalent, first thing to ask ourselves is it an acid? Does it have an H in the beginning? If it doesn't, if there's no H in the beginning, it's not an acid. And we simply use the prefixes like we talked about in the naming rules. And we'll add IDE to the name of the second atom. If there's only one of the first atom, we omit the mono in that case. And so a couple examples here. CO2, 1 carbon. We just get carbon. We don't have to put the mono because it's the first element. And 2 oxygens, so dioxide, carbon dioxide. N2O5, 2 nitrogens, dinitrogen, 5 oxygens, pentoxide. So N2O5 is dinitrogen pentoxide. If it is an acid, if there is an H in the front, then we just have to ask ourselves what is with the H. If it's a halogen, then it's hydro, fill in the name of the atom, ic acid, HCl hydrochloric acid, HI hydroiodic acid, and so on, like the examples we just talked about. If it's H plus a polyatomic ion, then we follow the rules that we just talked about a minute ago. If the end of the polyatomic ion is 8, then we get ic, that's one of our ic acids. If the end of the polyatomic ion is ite, we get one of our us acids. And so HNO3, this is from the nitrate ion, so we get nitric acid. NO2 is our nitrite ion, and so HNO2 would be nitrous acid. And so again, this flowchart is nothing more than the rules that I went over in the lecture. It's just now in a flowchart form to maybe help you organize your thoughts a little bit as you're doing more practice with these. As you do more and more, like anything, this is going to become a lot easier. And so I highly recommend that you look at a lot of the practice questions that are on the website. And so I hope this little addendum was helpful and you now know how to name acids as well. And I hope this flowchart comes in handy for you. Thanks a lot.